All right. Today we're going to talk a little bit about welding joints and the positions. Give you guys a little bit of additional information. I know we kind of briefly talked about it in the last PowerPoint last week, but we're going to go a little bit more in depth today and talking about those. So there are 5 basic weld joints that we're going to use. In fact, some of these we are actually not going to be using in this class, just to save some time because there's a lot of different stuff that we want to cover. But the 5 basic joints are going to be butt joints, lap joints, corner joints, T-joints, and edge joints. We are actually not going to be doing any corner joints or edge joints because those things are very similar to butt joints and then the T-joints. How we make the weld, the process, and all that kind of stuff is very, very similar. So we cut those things out in order to kind of save some time because we do have a jam-packed schedule in this class to be able to get everything done. But there's a couple different things that we're going to kind of talk about, as far as like rod angles and different things as far as those things go. So when we talk about butt joints, some of you have already started working on these butt joints. Some of you are going to probably get into that this next week. But obviously we have 2 pieces of metal that are going to be joined together, basically edge to edge. So if you kind of look at my hands down here, we're basically going to be welding those things. The one important thing that you're going to want to make note of, if you've never welded before, you've never done anything like this, it is very important that when you put 2 pieces of metal together, whatever joint it is, that you tack those pieces together. So what that means is putting a bead on both ends of where that metal is at. So that way the metal doesn't kind of move and adjust on you as you're welding. As you're welding, that heat will cause metal to separate if we do not actually put that tack together. So tacks are really important. It's just a small bead down, on either end of a joint to make sure that it holds it in place. So that way we're good. When we start getting into joints, the preparation and the setup and all that kind of stuff really kind of determines how well your weld is going to be. A good welder can take something that maybe wasn't prepared right and make it successful. But for you guys, what's important to note is that you're going to spend a lot of time making sure that it's set up right to make sure that you have the success. When you're welding projects together and you're putting stuff together, what matters more than anything and where you spend most of your time is the preparation and the setup of the material to make sure that things are measured correctly, things are cut correctly, they're set up correctly, they're in the right spots. About 90% of the work that we do on projects is actually cutting and setup, and only about 10% is welding. And it's really no different in this class. You want to make sure that you set it up to give yourself the best success. And if we're doing a butt joint, making sure that you have the correct gap on that joint, making sure that the things are set up, making sure that they're not unlevel with each other. All of those things are going to help make sure that you either have an easier time to get a good weld, or if you do it wrong, it's gonna make it a struggle to get that good weld. So preparing those things are great. Sometimes on butt joints, we actually do, different kind of joints. So we will actually grind down, portions of it. I think on the next slide, it'll kind of show you, those types of things. But we actually put little grooves in there if we're really thick to make sure that we get 100% penetration. In this class, we're welding a 1/4 inch thick metal. We don't need to mess with any of that stuff. We're simply just going to put little gaps in there to try to get that 100%. But if you're working with 3/8 inch thick metal, 1/2 inch thick metal, that's where you're going to actually go through and do some of these like single bevels, the single J's, the double bevels. And we take grinders, we take torches, and we cut these things out. We really don't need to mess with those things at all. The 2 that we're going to kind of focus on is doing a closed butt joint and an open, just a square kind of groove joint. And so that we can cut that with the hydraulic shear and then we can weld those things together. So whether or not we have a gap between there, so an open butt joint or a closed butt joint, those are really the kind of 2 things that we're going to kind of focus on in class. We mess with these things, all these other ones, as we get into some thicker metal. But just understand that we can do that if we need to, and then we just are going to layer welds in there. So you're going to layer one, and then another one on top of it, and then another one, and we're going to clean those things in between there. So typically, right, 3/16 metal or thicker is where we're going to start doing that. We're working with 1/4 inch thick metal, which is good enough. We can do that and we can get away with it to try to get that 100% penetration with just one weld there. So we'll break those things in class and we'll check with those things. A couple of things, just to kind of show you that some of these you don't necessarily need to really kind of focus on, but You don't need to necessarily know them and understand them. I'm not going to test you on the groove face angle and all that kind of stuff. But understand that, when we're welding with these things, it's very much like a stringer bead that we kind of start off with. You want to be 90 degrees with your electrode. If you're having bevels and you're having those things in there, you need to understand kind of where those angles are at, how we're turning that rod. We do have, like on this thing, we have our root pass. If we're making multiple layers on these things, you're going to make one root pass there, down in the bottom, and then you're going to actually just layer those welds on top. It really depends on how much material, how thick that material is that you're working with. I have no idea what's going on over here. They're messing with my office is right next to the bathroom. So if you guys are hearing this noise, no idea what's going on, but it's kind of frustrating me. Anyway, so if we're doing this in this class with that 1/4 inch thick metal, we're just going to make one pass. We're not trying to make multiple pass. We're not trying to do that. There is one weld that we will do a multi-pass on, and that's going to be a T-joint, our T-joint triple pass. And we do have the weld sheets. They are in the classroom or in the lab, the welding lab there. And so we can grab those. If you didn't grab it last week, we can grab it this week. As we start getting things passed and we start signing things off, we'll kind of cover those things. Some important things that we want to kind of make sure that we do kind of understand is kind of like our weld size, our joint preparation, like how we put those things together. The weld toe, this is going to be something that's going to be important. We're going to start talking about this as we start evaluating and as we start looking at that. The root reinforcement, the face reinforcement, and that all basically has to do with this weld and how deep we're getting this weld into there, which we don't worry about with stringer beads because we just want to get you to get a good bead. But then once we start getting those good beads and we start doing those joints, these are the things that we're looking at. How well does the weld toe tie into that metal? Is there undercut, meaning that we basically are going to cut that metal away, making this weaker? Do we get all the way through and get that 100% where we've got this little bit of a bubble on the bottom, which is kind of what we're looking for? We don't want a whole bunch where this weld just kind of drops down. Is my weld face, is that concaved or convexed? Convexed would be popped out like this. Concaved would be dropped down. Those would be indications that we are running too much heat. You don't really get this with stringer beads, but as you start doing the butt joints, that's when you're going to start seeing those things. If you have too big of a gap on your open butt joint, that weld could just drop through, and that weld face is going to be concaved, and then your root and reinforcement is going to be massive, way too much. And you see those things kind of in there. So we're looking at these weld toes. We're looking at how they tie in. We're looking if it's got a smooth transition with that stuff and how well those things go. Once you move on from those things, we've got some T-joints, and we don't necessarily have to do these in order. There's lap joints, there's T-joints, there's butt joints. Butt joints are typically a little bit easier because they're pretty similar to what you started working off with on the stringer beads. But with the T-joints, it's a 90-degree angle. If you flip this upside down, it looks like a T. One important thing that we want to note, okay, and this is going to be something that is going to be on your test. The joint on this is a T-joint. The weld that is going to be done is a fillet weld. Much like this is a butt joint, but it is a groove weld because we're filling in a groove, or we're filling in, doing a fillet, we're filling in kind of a 45-degree angle. And this is essentially where that weld is going to go. Those pieces, even if they're not necessarily a 90-degree, depending on the project and what we have going on, it's still considered a fillet weld, and it would still be considered a T-joint, unless we laid this metal all the way down, in which case it'd be a lap joint. But we got a 90 degrees. The edges could be squared. That's how we're going to do it. Again, you should be able to weld these things. We're not necessarily looking for 100% penetration because we're going to do 2 welds on either side. And between those 2 welds, you should be able to get that 100% penetration on there. That's going to secure this stuff. You can do a bevel groove on these things where you have some, metal that you kind of gouge out to be able to get that weld in, especially if we're layering these things, if you're dealing with really thick metal. That's typically where you're going to see those things. But we don't need to do that. We don't need to mess with that on the welds that we're going to do. One thing that we want to do on these T-joints, you're no longer going to have that rod at a 90-degree angle pointing straight up. You're actually going to be at a 45-degree angle, and your focus is going to be right in on this corner, right where those 2 pieces meet. You'll still have your side view angle where you tilt it 10 to 12 degrees, but you want your end view angle to be a 90 degree be right in between both of these pieces, because your weld should be at a 45-degree angle. You can adjust that up or down a little bit. Sometimes we jump it down because we are getting to the horizontal position welds where we're going to get that gravity that's going to want to drop out, and you're going to get a lot of undercut, which is going to basically burn this metal away, and it's not going to allow that metal to basically fill back in. So those are some issues that we're going to run across as we hit those. A lap joint, basically like a T-joint, except you lay it down. This is a lap joint, but a fillet weld. So it is the same type of weld, okay, but the joint is different because of how the metal is stuck together. Tacking these things, it's important to tack, I say, either in the middle like this, or we tack on two sides here and then the opposite two sides. What'll happen on these lap joints as you start welding them, if I only tack right here and then on the other side, this is like the end view angle, what'll happen is this metal is going to raise up and it's going to create a gap between these two pieces. Lap joints are incredibly important to set up correctly. Otherwise, you are going to run into issues where it's not going to tie in. If you look at the weld toe, either on the top or the bottom, you're going to have this kind of curved nature, and it's not really just going to tie in and kind of flow real nicely. These things should be like a ramp, especially on a lap joint. You should be a little ramp. If you imagine you're a little skateboarder, you should be able to run up this ramp and have no problem. You shouldn't hit any bumps or anything like that. It should tie into both of those, both the bottom and the top, very nicely. We shouldn't really be convex. We shouldn't be concaved. It should be a nice kind of flat 45-degree angle. If you don't set them up, if you don't have these things flat, you're going to have issues. We have welding pliers that you can use to kind of clamp these things together, kind of help make sure you get a good connection. Just ask me about that, and I can help you set those things up. The angle on these things, about a 30 to 45-degree angle. So you're not, or sorry, 30 to 40-degree angle. What you're not wanting to do is kick this thing up to, too terribly high. You want to make sure that you tie those things in there. But again, play with that stuff a little bit. Adjust those things. Focus, though, on that corner, not the top of this metal right here, but focus on that bottom corner. That's where a lot of people have problems. If you focus on that top corner, you're not putting that heat in that bottom, and that weld is just going to kind of curl over. It's not going to tie into that. You're not getting that penetration into that bottom plate there. And that's kind of what we're looking for. Corner joints, I'm going to show you, but we're going to run real quickly because we're not going to do these things. You can either have an open corner or a closed corner. Open corner, you're going to use a fillet weld to fill that in, a fillet weld to fill in the bottom side. If you do a closed corner joint like you see right here, this is now very similar to a butt joint where it's going to be a groove weld on the top side and it would be a fillet weld on the bottom. This is very much like a T-joint, and then it's very much like a butt joint, which is why we're just going to cut these things out. It's very similar. There are some differences, but we got to save time because we got a lot of stuff that we've got to go through. So just to show you what a corner joint is, whether it's a closed or an open, and just notice kind of where those corners are meeting on those things. I still may test you on the corner joints and open corner joints, like what they look like. So that's why we want to cover them, but we're not going to actually do these things in class. Edge joints, typically you see these a lot, like on sheet metal, especially where you're joining pieces together. You may have them coming together. You may have bevel grooves. You may have them to where they're an edge flange where it's kind of curved, or a corner flange where one's curved and one's kind of straight. And basically, you're just going to weld down the edge. It is a groove weld. Unless you bevel it like this, then it is what we would consider a fillet weld. But these things are very similar to the butt welds again, and they're not as common in a lot of welding that we do. So you really see T-joints and lap joints. Those are probably the two most predominant welds that we're going to do. Even butt joints aren't necessarily that prevalent in projects and as we're putting things together, but it really teaches you the same concepts on an edge joint versus a butt joint. So the edge joint is just basically the pieces are going to be longer and you're just welding on the edge of the metal instead of having them kind of flat like on a butt joint. But the weld, the process, all that kind of stuff is really the same. So a weld is obviously a fused joint between two or more pieces of metal or non-metal. It could be non-metal, although in this class we are only going to be dealing with metal. And we talked a little bit about fillet welds, okay, where we have the intersection of the surface, right? So lap joints, T-joints, those things are where we're going to see the fillet welds, open corner joints. We're going to see those. The groove welds is going to be on the butts, which is going to be on the edge welds. It's going to be on the butt welds as well. So those are kind of the most popular things that we see. Fillet welds, this is kind of what we're looking for a little bit on these fillet welds. We do have a little bit of convexed weld that's going to be in there, and that's typically what you're going to see. You could see basically where this blue mark is at is would be like the penetration that you're getting. You're not going to get 100% penetration on these welds, but we're looking to try to get in there as deep as we can and fill that stuff in. You want these pieces to tie in. You want them to kind of be smooth. You do not want to have undercut. We're really looking at the weld size. We're looking at the effective throat. So that's going to be how deep they go. We're not going to cut these things and look into them, but what we see on the surface of these things is really going to indicate what is going on underneath these things. Where's the leg size? Is it, focused on one piece versus the bottom piece? And you really want to be in between both of those because that's going to indicate that you're getting that same penetration through both pieces. And it's going to join it together. If you're really heavy on the top side or real heavy on the bottom side, you're going to miss out on some of the penetration, and that joint is going to be weaker and it's not going to hold as well. And that's really what the purpose of these welding is of the welding is to hold stuff together. A weld, when you put it together, should be stronger than the base metal that you are welding it to. And so that joint and all that kind of stuff, if you get a good weld, it's going to be stronger than the base metal, and the stuff is not going to break there. It's going to fracture somewhere else. That is ideally what we're looking for. What you've been doing up to this point is going to be just a one pass filler metal, but sometimes we do have to make more than one pass. You are going to do a triple pass, and I will explain this when you get to it, the kind of process that we need to do. But that first pass is the root pass. Typically, the root pass you do not see. You're going to do a second pass on the triple pass T joint, where you're going to weld one on the bottom, and then you're going to do a final pass that's going to be on the top. You are going to see the two top welds. If you're doing a butt joint and you're doing these welds, you may end up doing 10 or 12 if it's really thick metal welds, just layering them one after another after another. But on the butt joints, your final pass typically is going to be a very wide weave bead pass, and it's going to cover all those other passes there. And it's going to be a lot wider. So this picture kind of shows you kind of your root pass. You layer your second one, and then you have a weed beave that's going to go over the top of it. That is just going to basically cover it, make it look like it's one weld. Again, that's on thick stuff. We're not going to mess with that in this class. So we'll just kind of move on. What you've been doing is stringer beads where we're kind of running them. If you want to do a weave bead, you can make that a little bit wider. That's kind of where we talk about putting a little bit of motion in there. It kind of controls the heat a little bit. There are different patterns, different things. This one talks about a crescent motion, and that's typically what you have, but you could even do a circular motion. But typically, if you're doing a weave bead, you're going to be moving from one side to the other versus maybe a whipping motion that some people do where they go up and back, up and back. And we do that on 6011s, especially when we talk about vertical ups where we're having the metal straight up and down and we're welding in the upward position. They can be challenging. We have to control that heat, but we'll talk about that as we get into those things. Joint geometry is defined as the shape, dimension, and joint. If you took a cross section of that weld prior to welding, setting this stuff up, making sure that we have things, aligned right and set up correctly is going to help make sure that you get the best results. It's going to make sure that you get the best penetration, that you get down into the bottom of that weld joint. If you are going to be cutting, we are doing machining on well, not really machining, but we are doing a shear, which I guess is a form of machining, but it's basically just going to chop it. It's going to cut it. We can do flame cutting. We can do gouging, and we can actually take mills on these things where you basically cut that metal out, essentially just kind of drill the whole side of it where it's nice, bright, shiny metal. The better prepared the metal is, the better off you're going to be. On metal, on mild steel, you get what we call a mill scale on it. That is going to be kind of that dull gray color on there. If you want to help make your welds better, you can take those things to a grinder. You can grind down that until we have bright, shiny metal, and it's going to help make sure that any impurities that are in that mill scale are going to be knocked out, and you're going to have a better chance of success with your weld. You don't necessarily have to do this on sheet metal arc welding. When we get to like TIG welding, it is absolutely necessary to clean, to prep, to make sure everything's good. But even on sheet metal arc welding, on MIG welding, cleaning it down to bare metal will help. And if it's something that is a very critical part, we want to do that. If we're just kind of trying to build some skills, we can kind of cut that part out, and you can weld to where you're like, you know what, I need to be able to hold the arc angle. I need to make sure that I got my right speed. Those things are not going to get affected by the mill scale. It's just basically the quality. Do we have porosity? Do we have those holes kind of starting to form, which is going to make that weld a little bit weaker over time? Those are the things that we need to kind of, that we're focusing on when we clean. So if you're not getting really great welds, cleaning it is not going to necessarily help you a ton, and it's going to be a lot of time because it can be very time consuming to do that. But you are more than welcome to clean those things off, and more than welcome to kind of make those better. So we want to make sure we align them. We want to make sure that we tack these things together. That's going to be on any joint. We want to tack on different spots to make sure it's held together. We can use magnets. We can use, other things. The important stuff is if we're using like clamps. The important thing is when we are using magnets, we only tack with the magnets on there, and then we pull the magnets off. Otherwise, we destroy the magnets. And so, there's a lot of different ways. We have different tools that we can hold things together with. You can even use bricks or whatever. If you're struggling and you're having issues, ask me and I can help you out. So we already talked about this. Completed weld should be as strong as the base metal. Actually, it should be stronger. It should be able to penetrate deeply into that base metal. That's what's helped going to give it the strength. It's going to join these two pieces. We are doing fusion welding, meaning we are joining it with the parent material, and that material obviously has to match to be able to join those things because we can't join dissimilar metals. Not with a fusion weld, but we're actually melting the parent material and adding that same material back into that to help make sure that we give it that strength. So we talk about penetration. That's where we're talking about how deep it's actually going into that metal and joining with that parent material. We can do different joints, and I know we've talked about these, but we have flat position. That's basically the stuff that we worked with. You set the stuff on the table, you weld it. Horizontal is going to be when at least one piece is up vertical, and gravity is going to want to push down. We have the vertical position where we're going up or we're going down. Going down is easier than going up. We will do some welds kind of in both of those. And the overhead position is when you're welding and you're welding kind of upside down. Runs very similar to flat position. The only difference is it's very hard to keep your hands up because your heart needs to pump that blood, and it struggles after a little bit of time holding your hands up. Plus, you get a lot of sparks that fly down on you. We do have some of those welds, a little bit of each of those welds that you are going to have to do. How we position it, how we, put those things together, and how we position our rod really depends on what joint that we're doing. And so when you think about the imaginary access point, that's going to be right through that weld, right where it's at, lengthwise, right through that center where that weld is going to be. There are a lot of different joints that we can do, how we angle those things and how we adjust those. We're just going to change those. The best thing to do is kind of ask, kind of help, and just weld and do it and find out and see what that weld looks like. Look at that root, the root toe, and look at how it's tying in, and then adjust some angles and go from there. That's really the best things that we can work with. We talk about really two angles. I talked about it in class. I use the terms end view angle and side view angle. That's what travel angle and work angle is going to be. When you think about travel angle, that is the direction of travel. So when you're going it, this is 10 to 12 degrees. This is like the side view, about 10 to 12 degrees. Again, that does vary. It's not like set in stone, but that's typically what we're looking for on that. And really all welds, with the exception of vertical ups, we're looking about a 10 to 12 degree angle. We can either do backhand welding. That's kind of what I start you guys off with, but you can do forehand welding. And in some instances that's there. Some people can do both in any instance. Backhand welding is probably just a little bit easier than forehand welding because you can kind of see things a little bit better. It's a great way to kind of start off with, but we do forehand welding, and there are some instances in where you are going to absolutely have to do forehand welding. And that's when you are pushing that weld. If you notice here, the tilt is kind of tilted in front of where that weld is going. So that weld is kind of pointing back. This is why it's called backhand welding. In forehand, that angle would be tilted the opposite direction, and you'd be pushing it instead of pulling it. So that's the difference between backhand and forehand welding. And some people will have that. They talk about, differences and what's better. You can argue points all day long on that stuff. But backhand welding typically is a little bit easier, especially for beginners. The work angle or the end view angle, that's going to be where that rod is at in relation between these two pieces. If you look at the end view of it, That's why I like to call it in view. But if it's a T joint, you want to be about a 45. If it's a butt joint, you want to be a 90 degree. And you're basically just, mimicking where that weld's going to be and putting it right in that center there. So on this, T joint or corner joint here, you want that weld to be a 45. Okay, so you're going to set your angle at a 45 and you're going to make that adjustment. Work angles usually, right, 90 degrees straight up and down, or 0, kind of depending on how you look at it. Fillet welds, 45-degree angle. Drag or push angles are going to be, 0 to 40 degrees. If you're pushing, you may be a lot, especially if you're doing vertical up. You may have that rod at a 45-degree angle. Flat position stuff, okay, you're going to have a slight tilt, 10 to 12 degrees. We're not going to do any gouging in here, so we don't need to worry about that large push for 85 degrees that we're going to do. So hopefully this helps you out. And I look forward to seeing you guys in class this week. So we're going to stop this and we'll see you guys Thursday and Friday.